Case study, externalities. Question 1. Electric cars can be best described as A. A positive consumption externality, B. A positive production externality, C. A negative consumption externality, D. A negative production externality, and E. Both A and B. Positive externalities.
First, talk about the positive consumption externality, and this is where the act of consuming a good passes on external benefits to the rest of society in conjunction with the private benefits enjoyed by the individual buyer. Then there are positive production externalities, and this is where the act of producing the good passes on the external benefits to the rest of society in conjunction with the private benefits enjoyed by the individual buyer.
Negative externalities. A negative consumption externality where the act of consuming a good inflicts external costs on the rest of society outside of the private cost incurred by the individual buyer. A negative production externality is where the act of producing a good inflicts external costs on the rest of society outside of the private costs incurred by the individual buyer. Electric cars, private costs and benefits.
As we already know, equilibrium price of electric cars and all goods in general will only take into account the private costs and private benefits of a good. So we'll run through all the private costs and benefits from the firm side and from the buyer side. On the firm side, the private cost is of manufacturing the electric cars, the cost of materials, machinery and labour. However, the private benefit that firms gain is generating revenue and profit when they sell electric cars.
The private cost to the buyer would be the purchase price that consumers are willing to pay, and the private benefit of the buyer would be transport from A to B. Consumer externalities. The act of buying or using electric cars contributes to zero tailpipe emissions, which in turn has a positive influence on the well-being of society.
This is because an electric car itself does not release emissions like a combustion engine does, where the energy starts with the fuel that powers the engine, which in turn releases the byproduct via the exhaust. In terms of electric cars, is that the negative externality, greenhouse gases, is a byproduct of the electricity that is created in the first place.
Since electric cars don't have tailpipe emissions, the negative consumption externality is moved upstream to the power plant. For electric cars to be completely sustainable, the power would have to be entirely sourced from renewable energy such as hydro or wind. Considering oil, coal and natural gas are Australia's largest sources of energy, electric cars won't entirely be a positive consumption externality until the grid itself becomes sustainable.
So when we talk about the electric car itself, they do create a positive consumption externality as they don't have negative effects on the direct bystanders surrounding the consumer. The issue is that electric cars can still have a negative effect on greater society, as the power it requires may not be sourced in a sustainable way. And using the example of Australia, electric cars won't have a complete positive consumption externality until the grid itself goes green.
Therefore, electric cars would still be best described as A positive consumption externality despite the setbacks we explained, as they are still seen as a more viable option compared to combustion engines in terms of sustainability and do not have a direct negative impact on bystanders. Electric cars have the capacity to be carbon neutral only once the power is sourced from renewable energy.
Produce externalities. The act of producing cars, production, creates positive external benefits to society such as zero tailpipe emissions, which in turn leads to cleaner air. They are the leaders and innovators of the car industry, and which constantly pushes the envelope in technological advancement.
These advances create a superior vehicle which directly challenges combustion engines. This may mark the dying days of combustion engines being used on the scale they are today.
Even with these great benefits, electric cars still have negative production externalities, as manufacturing involves many separate inputs which all have a negative impact on the environment. For example, the extraction of raw materials for production.
When we talk about the production of electric cars, it is seen as a positive production externality as it creates innovation in the car industry, making electric cars more viable and gives the consumer the ability to have zero tailpipe emissions. Unfortunately, electric cars will always have a negative production externality, as it would be near impossible to have every single input of production run on sustainable energy.
The only negative production externalities which can be solved with renewable energy is the transportation of inputs and electricity which powers the assembly line side of manufacturing.
Taking the positive and negative production externalities into account, electric cars are still best described as B, a positive production externality, as advancements in technology and improvement in overall air quality outweigh the negative production externalities.
Question 2. According to the article, economic research finds that the environmental benefits of electric vehicles are, for now at least, marginal and worth less than the subsidies paid for them. The article then describes electric vehicle subsidies as excessive and inefficient. Which graph about the electric vehicle market best represents this statement?
Responding to externalities. It's important to point out that internalizing externalities is simply placing a tax or subsidy in order to encourage or discourage the production and consumption of a good.
If an externality is negative, a tax is implemented in order to discourage the production or consumption of a good. If an externality is positive, a subsidy is given in order to encourage the production or consumption of this good.
In order for an externality to be correctly internalized, taxes and subsidies must be of equal value to the externality in question. It's easy to put a numerical value on a tax or subsidy, but putting a value on externalities is more difficult. This is a conundrum that governments face. The following graphs will reflect this problem. Graph A. Graph A shows that social marginal benefit is above private marginal benefit. This first part is correct. When social marginal benefit is above private marginal benefit, it shows that society would like to consume or make use of electric cars to maximize the added social benefits of electric cars in conjunction with the private benefit enjoyed by the individual buyer.
However, the second part of this graph is incorrect. The question states that current subsidies are excessive. This means that the value of the subsidy is larger than the supposed value of SMB. However, in graph A, the per unit subsidy is below SMB. This presents the value of the subsidy being smaller than the supposed value of SMB. So we know graph A is out of the question now.
Graph B. Graph B again shows SMB being above PMB. The question describes current electric car subsidies as excessive, where in fact graph B shows the per unit subsidy being equivalent to the SMB. This is ideally where the value of subsidy is equal to the supposed value of the SMB, which is a cleaner environment.
In saying this, we now know that graph B isn't the answer because we know the question has already stated that the subsidies are currently overvalued.
Graph C. Graph C is showing SMB is lower than PMB, implying that electric cars possess a negative externality.
However, we already know that electric cars are best described as a positive consumption externality, so the SMB cannot be lower than PMB.
This graph would be more representative of combustion engine vehicles as the social marginal benefit outweighs the private marginal benefit.
Therefore, we know graph C isn't the answer either. Graph D. This leaves graph D as the only possible answer. Here, SMB is above PMB, correctly indicating the positive externality associated with electric cars. The graph also shows the per unit subsidy being above the SMB, correctly reflecting the excessive electric car subsidies mentioned in the question.
It represents a situation in which the value of the subsidy being greater than the supposed value of the social marginal benefit.
So we know graph D is now correctly the answer.
Question 3. In the article, Roberts recognized that climate change is significant enough to warrant transferring consumer demand from oil to electricity. Suppose that using these subsidies, consumers substitute towards using electric cars and away from cars that run on petrol and diesel. Which graphs best represent what will happen in the electric car market and the general car market? Substitute and complement goods. Substitute goods, all things being equal, is where two goods in which an increase in the price of one leads to an increase in the demand for the other. Example, butter and margarine.
Complement goods, on the other hand, all things being considered, are two goods in which an increase in the price of one leads to a decrease in the demand for the other. An example of this are video games and video game consoles.
The question has outright stated that general cars and electric cars are substitute goods. Now we can start looking over the graphs. Graph A. In stage 1, we see electric car subsidies being placed on consumers. They should indeed increase the demand for electric cars since it is giving consumers extra incentive to purchase electric cars.
The right horizontal shift in the demand curve is also correct. Direct changes to price will cause movements along the curve, but changes to non-price factors, such as a subsidy, will cause shifts in the demand curve, since it affects quantity demanded at every price point. So far, graph A is correct.
In stage 2, the rise in equilibrium quantity and price is simply a graphical result, and so should remain correct. Economic theory suggests that since there is an extra incentive for consumers to purchase electric cars, they are willing to pay a slightly higher price.
Conversely, firms recognize this consumer behavior and supply a larger quantity of electric cars in hopes of generating more revenue and profit. So far, graph A is again correct.
In stage 3, the question establishes that electric cars and general cars are substitutes, so the graph is correct in showing a decrease in the demand for general cars.
Furthermore, the whole demand curve shifts left in response to the increased demand for electric cars, which is a non-price factor. So graph A remains correct. In stage 4, There is again a fall in the equilibrium quantity and price of general cars, and this is simply a graphical outcome. It is also simply the reverse of what happened in the electric car market.
All 4 stages correctly represent the outcomes in the electric car market and the general car market. As such, the answer is graph A. However, we will run through the other 3 graphs to see where they first falter.
Graph B. In stage 1, quantity demanded is stated to have increased, which is partially true. However, the graph represents this as a movement along the demand curve.
Such a movement can only be produced through a direct decrease in electric car prices, but we know that a subsidy is a non-price factor and should be shifting the whole demand curve, which is an increase in demand as a whole. So we know graph B isn't the answer. Graph C. In stage 1, the graph states that the market price for electric cars will increase, which is partially true.
However, the graph represents this as a movement along the demand curve. If a subsidy, which is a non-price factor, were indeed in place, it would have shifted the whole demand curve right. So we know graph C also isn't the answer. Graph D. Both stages 1 and 2 here are identical to graph A and have already been previously explained to be correct, so we will gloss over these.
In stage 3, the graph assumes that electric cars and general cars are complements, hence the increase in demand for general cars. However, it has already been established that there are actually substitutes, so the increase in the demand for electric cars should cause a decrease in the demand for general cars. So we know that graph D isn't the answer. Question 4. Do you think a target-based policy would be better than a cost-based policy? Why or why not?
Well, let's compare both types of policies. Cost-based policies focus on comparing the benefits of a policy to the costs incurred in its implementation. Target-based policies focus on reaching specific benchmarks. Application to electric cars. The article, in fact, gives examples on how each policy could be applied. In the case of cost-based policies, we could tally up the environmental benefits of a policy using, among other things, the social cost of carbon emissions, and compare them to the cost. On the other hand, it also gives a perspective on target-based policies. We decide what temperature threshold to avoid, say 2 degrees Celsius over pre-industrial levels, and work backwards from there.
If a target-based policy were implemented, the cost of subsidizing electric cars would outweigh the current benefit of a cleaner environment and technological advancement.
Resources have been inefficiently allocated because money that was spent excessively subsidizing electric cars could have been spent on projects that return greater benefits at present. In fact, the article references this conundrum. It says to commit to a target is to say, in effect, that it is worth any cost to get there, and this is clearly not rational thinking.
If a cost-based policy were implemented, electric cars would be subsidized only to the point where subsidy costs are equal to the benefits provided by electric cars. Extra resources would be available to fund projects that provide greater benefits at present, thereby achieving an efficient allocation of resources.
So, in a pure economic sense, and in the eyes of the benevolent social planner, a cost-based policy would clearly be
Reasoning behind target-based policies.
People still push economic reasons aside in lay of other motives. This is why target-based policies rise in popularity. For one, oil is a finite resource and will only become more scarce and expensive. We should adopt electric cars as soon as possible before oil scarcity significantly impacts the general car industry.
Climate change is putting pressure on people to move away from combustion engine vehicles. We should adopt electric cars as soon as possible to restrain climate change as soon as we can.
The whole power grid will eventually have to transition to a fully electrical system, so we should adopt electric cars as soon as possible to accelerate the implementation of an entirely electrified power grid.
We can see that there are reasons why people campaign for target-based policies in the electric car industry, but we as economists should be primarily concerned with the economic problem, to satisfy unlimited wants with limited resources. In this sense, we need to pursue an efficient allocation of resources.
Therefore, cost-based policies would be superior to target-based policies in application to electric cars.
This concludes our presentation on externalities.
We hope that we have given insight into the complexities of externalities in relation to the electric car industry.
Thank you for watching.